Sauce here. This is a video lesson on solution process. The process for finding the solution of an equation. For example, we could be given the equation x divided by 4 is equal to 10. And we want to find the value of x that makes that equation true. We may be able to solve simple equations in our head or find those values, but there's a process that we can rely on to solve all equations. Given equation, with a variable, there is a process to solve for the variable. To solve for a variable and find the solution to an equation are slightly different things. But when we solve an equation that has one variable in it, then we will find the solution. What it means to solve for is to get the variable alone and positive. Alone meaning by itself with no other numbers and operations and symbols. On one side of the equation. So we have an equation and we solve for the variable, which means, in this case, get x alone and positive on one side, then the other side will be the solution to the equation. And the process to get this done follows these two general rules. To undo an operation, and operations are the actions we take with numbers, add, subtract, multiply, and divide, as well as others. To undo an operation, do the inverse of what you see. In our example, we see that x is being divided by 4. We want to undo the division by 4 to get x by itself. The inverse of division is multiplication. So if I multiply by 4, I'll undo the division by 4, leaving x. But there's something else to take into consideration. The second general rule. What you do to one side you must do to the other. So we chose to multiply this side of the equation by 4. If we're going to preserve equality, we have to do the very same thing to the other side. We have to multiply the 10 by 4. And when we do, on this right side, we get 40. X has been solved for because it's alone and positive on one side. and x is equal to the solution to this equation, the value that when substituted in makes the original equation true. 40 divided by 4 is equal to 10. Let's have another example. Our equation is 3x plus 1 is equal to 13. And in this example, we're going to need to undo two operations to get x by itself. We want to solve for x by undoing the multiplication by 3 and the addition of 1. We can undo adding 1 by its inverse, subtracting 1. And we'll need to do that to both sides. When we do, the plus 1 and minus 1 cancel out, leaving the 3x. On the other side, 13 minus 1 is 12. X is not alone and positive yet. We're still multiplying by 3. I'm going to do the inverse of multiplication. I'm going to divide by 3. What I do to one side, I must do to the other. Multiplying by 3 and dividing by 3 cancel out, leaving x. 12 divided by 3 is 4. Now we have the equation solved for x. 4 is the solution to the original equation. One more example. Three x plus 3 is equal to 5x minus 7. We have a variable on both sides. We want to get x to be alone and positive on one side. I have several choices. I'm going to choose to get rid of the minus 7 on this side. By doing the inverse of subtracting 7, I'm going to add 7. And if I choose to add 7 to this right side, I must add it to the left as well. I'm going to make a second choice in this step. I'm going to subtract 3x from this side. If I subtract 3x, then I must subtract 3x from the other side as well. So here we can see that in showing our work, we're choosing to do two separate operations to both sides. We're going to subtract 3x and add 7 to both sides. Let's see what happens when we simplify our work. Subtracting 7 and adding 7 cancel out. But we also have 5x minus 3x. These are like terms, they can be combined. 5x minus 3x leaves 2x. On the other side, 3x minus 3x are going to cancel out. And the 3 plus 7 make 10. I haven't got x by itself yet, but if I undo multiplication by 2 with division by 2 and do that to both sides, these will cancel out, leaving x. 10 divided by 2 is 5. Notice that in this example, x ended up being on the right side, but it's alone and positive, and it's equal to the solution 5.